All right. Welcome to the 20th call we have had now about the Wharf project and its progress. Small crew here today. We're going to go over some updates, talk a little bit about where the table stuff is at, where the documentation's at, and may or may not move into some conversations. Might be a shorter one, but at least provide this to give a little bit of an update. So I guess to kind of start on maybe the documentation side, um, there's not a ton in here yet. We have a lot locally and elsewhere that we are starting to merge in, but this documents repository under WharfKit is currently where the documentation is going to live. This may all get moved into just the website repository for future viewers. If you can't find the stocks repo, it is now part of the website. We're kind of debating the build strategy for the website and how to avoid conflicts as we're working on code versus documentation. So some things in flux going on there. But in this repo, there are a number of things. It's going to be broken up. There's Antelope documentation, which is going to be just the Antelope formerly known library known as ESIO core. We'll be going over covering all like the core types, usage of this library itself. An example of that so far is the asset class, which I worked on a couple of weeks ago and uploaded just kind of as a placeholder for the build process to work on. These documents are all going to be written in Markdown. The website itself ingests them and then formats them and builds tables of contents and things like that. But really, we're trying to, within the Antelope side, build it so that each of the primary or like these core types explains what this type is and the utility that it has, like how to use it. So for the asset, we're talking about how you can get to the balance, which just gives you the number, being able to access units to do your math, so that way you're not dealing with floating numbers, accessing symbols, creating them, how you can create them from a bunch of different methods. Like we're trying to dive in so that way there's all the various use cases for those specific types. This is very much the manual, like the handbook for the code itself. That's kind of the entire point of the documentation section itself, is to serve as reference material. There will also be a guides section that's actually going to have like written guides and tutorials. That won't be part of this section. It'll be kind of a section unto its own. So the final website will have those two places. One of them that is more of a get started. Here's how you use these things. It'll be like, how do I load a balance on a website? And then we'll talk about from scratch how to do that. And then it'll reference documentation like this to get into the weeds about how to do specific things. On the flip side, in the documents repository, we'll also have this Wharf side of things, which is going to be all about the various components of Wharf. There is currently one document in there, which we pushed forward on because it was part of one of our next milestones. It is about the user interface, and it is written from the perspective of somebody that wants to build a user interface, and it defines the specification for how you would implement it on your own. There are other aspects of the user interface, like how you actually just use one in an application, which is this very first section. And that's as deep as we're going to get for developers in this manual type environment, for people who are just implementing. And there will be another document from the perspective of a plugin developer about how to use the user interface. And that'll be linked from this document as well. It's been interesting writing the different documentation from different perspectives of the kinds of developers that are going to be using this documentation. You got just currently, like for this, you have the three. You have the developer building a web app who just wants to use it, the developer building a user interface who wants to build a custom one, and then the developer who is building plugins that wants to leverage the user interface for interactivity. So we're navigating those waters and figuring out how best to structure the documentation so that way from those various perspectives we can get capture that information that's relevant to them, because what's relevant to one is not going to be relevant to another perhaps. So lots of experimentation and formatting and figuring out how this best fits. But to kind of loop back on all of this, there are, I think, currently 48 documents we have started. Obviously, there's only a handful. I think there's only 5 actually uploaded to GitHub right now. It's because most of them are really rough trains of thought with code examples. I think maybe the ABI is one that got uploaded that's kind of like that. Yeah, this one doesn't have much written content yet, but we went through and created all of the actual code snippets that show it in action. And this one's all about using ABIs. So we're going to have to write a couple more about ABIs for that perspective side of things again. And I bet you that one's going to happen closer to the time the contract kit is in a more stable. So documentation is really heavy focus on our side right now. Like that is primarily what I'm working on. A couple others on the team are primarily working on that as well, whether it's from the website perspective or making sense of the structure, making sense of the content, proofing, all that fun stuff. So this is eating a lot of our time right now, but in the end, hopefully it'll be really valuable for new developers to come in, be able to take advantage of this tech stack and build web applications, whether they be, actual in your browser applications or something that runs using web technologies on a server. So kind of wandering into the next topic, the other big thing we're working on is the contract kit. We talked about this on, I believe, last week's call, and maybe even well, not last week, but the last call we had, which was 2 weeks ago, and the call before that. The contract kit kind of serves 2 major functions. One is helping developers interact with a contract, and the other is to help developers retrieve data from a contract from the tables themselves. That latter half is what we've been looking at for weeks now, and it is really about how we wrap the retrieval of data in a more familiar syntax, because the actual raw API is not incredibly friendly unless you know exactly what you're doing. So I figured real quick I'd kind of go over where it's at today and where it's heading, because as of last night, we have our weekly developer powwow the night before this call. So whenever we look at this code, typically there's changes incoming from 12 hours ago or whenever we had the conversation. So those aren't implemented yet, but this is going to introduce a new primitive called a table, and you'll be able to create tables manually if you want to. Otherwise, the contract kit itself will generate these and introduce a whole bunch of optimizations that really help the table function a lot better. You'll also be able to access these directly from the other object, which is the contract object, which is out in the root folder. And this, again, is another kind of primitive object that developers could create manually, but will also be automatically generated based on the contract you've specified. So jumping back to the table and the querying we were talking about, currently we have 3 query methods. I think we talked about this last time as well, but now there's actually implementation details of a lot of this. We have a where call, which we're actually going to rename. I think it's going to be renamed to first or something. Or no, that's all. Where is going to stay where. Ignore what I just said. And what this does is, let me open the tests folder. That might actually be better to highlight what some of these do. Like all of the other libraries, these are going to be driven by unit tests. We're doing kind of examples where we can actually build these out and make sure they work and reliably reproduce that they work. Like I mentioned earlier, you can manually create tables. We're doing that in our unit tests because we're not testing the code generation at this point. So a developer can create a table manually. You kind of specify the contract, the name of the table, you give it an API client. And then once you have that table object, you'll be able to call things like where on it. This contract is one that one of our team members built years ago. It was a blogging platform, kind of like Medium. So it had a trending table that it has trending posts in it. Like these are the blog posts that are trending. So that's the sample that we've been testing against, the table we've been testing against. And that's just to give a little flavor as to what we're querying for here. Here's the table object itself, and you can call where on it. And when you call where, you would pass in the name of one of the fields. Like this is actually, I think, a secondary index. I may be wrong here, but I'm pretty sure it's not the primary index. And it's querying where the score itself is between these two values. And the table itself converts this into what the actual Node.js API is expecting, that call. So we're really trying to abstract and make it so it's more contextual to the developer who's actually building the contract or interacting with the contract, rather than the large JSON blobs that we have to write today using the Git table. In the where call, you can see that we're actually doing the logic to convert all of that into the JSON that's required for that API call and performing the API call. And then we're also returning table cursors, which this is changing a little bit. Just as of last night, we are going to make it so that the idea of loading records and getting a cursor are going to be separate calls. I won't get super deep into that, but it'll be a little bit more intuitive than it is today. Right now, there's some oddities in that some calls return rows and some calls return cursors, and we're basically going to standardize that. But you can see in this call that the table cursor here, which will change slightly, returned an array of rows, and we're ensuring that the scores that came back in all those rows matched the query parameters we defined. So we're going to be writing a lot of tests like this to test the permutations of this. And in the background, you can see it's doing things like using this object to figure out what position the index is in, because in the actual call, we just specified score. That's the name of the field in the ABI. And the where call and the table class and all of that will convert the named field into whatever index it's supposed to be. And then also, append all the information. It templates out the more complicated call. So if this ends up being too abstract for developers, like, we are open to feedback on that and can always maybe make it a little bit more, I don't know what the right word is, customizable. Like maybe the query is too limiting in what most developers want to do. But in the meantime, like, developers always have this get table rows call to fall back on. So this whole effort is really to simplify what exists today, so that way there is a stepping stone into the more complicated side of things. Other calls, we also have find. This one returns a single table row. Like, you're still able to provide query parameters, and we still do the translation of the query parameters. But in the end, we're just going to return you a row. You are trying to find something, something specific. And down here, on the same Decentium contract, we want to find ID number 5. Like, it'll map, using the ABI, it'll map ID to whatever index it is. And then it'll find post 5, and we're doing a assert that makes sure that we're getting the same result back. If you were querying like a token contract, you'd be able to say you'd have the table contract or the table object right there loaded up, and you'd say find, and then maybe the field name is account, and you could pass in an account name, and it would query the balance table or whatever it is you're querying for that account name and just return you that one result. So this, instead of writing out the entire query where you're specifying the index, the lower bound, and the upper bound being the same value, and then pulling out that individual record from the results of the API, this is just a very shorthand way to be able to pull one record out using the find method. So we have where, we have find, and then we also have all. All is the one that's getting renamed. I believe we landed on first is what we're going to call it. And this just returns rows. Like if you had a table with 100 rows, it will use the default sort order. It'll find the first X number of rows. By default, we have it set to 10. We don't know if that's a great number yet, but we're kind of debating on that. Developer can always pass in whatever limit they want. So if they want 100 rows or 1,000 rows or whatever it is, it will just start at the top and return that many rows. We are working towards making that also guarantee that it'll return the number of rows you asked for. That may be a separate call. We've been going back and forth on that a little bit. And this is to get over the quirky behavior of Node.js where you can call get table rows and say, I want 100 rows. And Node.js may not return 100 rows, even though there's 10,000 that exist. And this is because Node.js has a hard execution cap on how long it'll process an API request. And if you say, I want 100 rows and it takes longer than that execution cap, it'll just return what it has so far in its internal cursor. So we do want to make a command so that way you can say I want 100 records, and if it only returns the first 80, the command itself will be intelligent enough to know that, hey, we didn't get enough records. We know there's more table rows because there's a next key on the result itself, and that we should go out and fetch the next 20 rows, so that way we actually have 100 rows. So this will give developers a consistent way to retrieve the number of rows they actually want. Developers that are building today that are using get table rows, they all have to write this logic themselves. We have it in Anchor, we have it in Unicode, we have it in a few of our projects where we want to display a certain number of rows on our user interface. Like we have our own pagination and we're expecting, X number of results to be displayed on each page. And when Node.js doesn't respect that, then we have to write additional logic that then seeks out that additional data to make it so our pagination makes sense. So this all call, going to be renamed first or something along those lines. Either this or another call like that will be what's responsible for doing this for the developer. We're also hopeful that by using, I don't know if it's actually turned on yet because we need the code generation in place. I'm looking in the wrong spot. Nope, it is not there yet. We will be setting JSON to false on all of our table queries, which I know most developers don't do. It seems like every code documentation example you see for get table rows call, they all say, set JSON to true, and it makes it so that it returns decoded data from the call itself. You're asking the server to decode the raw data and return it to you. And this is actually in part why some of those API requests hit that limit and don't get all the rows that they want. It's because Node.js is actually spending that time decoding the rows and then returning you the human readable data. The contract kit doesn't need that. The contract kit has the ABI, it has the everything it needs to actually decode the raw data. So these calls will all be optimized so that the request to the server doesn't need to do the decoding. We just need the raw binary data. And then once it comes back through the contract kit, we will then decode it in the client. So that'll be a lot more efficient for API requests. It'll lessen the burden itself on the APIs because the APIs will be doing a lot less deserialization. And it'll put a little bit of load on the client, but deserializing data is not much. Like the HTTP request is probably heavier than the deserialization of the data itself. So yeah, those are kind of the three calls we have, some of the optimizations that are coming to them. These unit tests are all passing currently. I guess just to kind of quickly show that all call, you can see right now we have the table and we're just calling all. This data is indexed on primary key, so it's just counting upwards. But we're iterating over the cursor and it's matching the correct IDs. So we're actually getting that data back just calling all. Like you don't have to pass that massive JSON block of code to get these results. So here's the passing in a new limit. And then I guess the other feature that's there and working is this more on a table cursor. This is changing how it behaves a little bit, but the goal is so that way if you call all with a limit of 2, it's going to give you 2. And then on the cursor itself, you'd be able to call more and it'll give you the next 2. So it's kind of a helper for pagination. It'll remember the query itself is embedded in the cursor. So it knows to continue iterating along the same path that you originally defined. This will be useful in like where calls as well. You can see we're querying from 5 to 7, but we're only asking for 2. So the first request only returns 5 and 6, but when we call more, it also brings in 7. Stops at that upper bound, that range that you're querying. So yeah, development's coming along. Now that we're actually starting to use it in unit tests, we're finding things we do and don't like. One of the big topics we covered yesterday was iteration over cursors. And I know we're getting pretty deep into kind of database theory at this point for this call specifically. But we definitely want to create something that feels familiar to developers in the wider web development space and apply it to the Antelope smart contract data structures. It'll hopefully bridge that gap a little bit and make it a little easier for people to get started. And then once they want to get deeper, they can get deeper. But hopefully there won't really be a need to go deeper because this will actually be a little bit more intelligent than what we have. So, and in the future, if Antelope's APIs ever change, we get better APIs, we get more flexible options, we can adopt this kind of query cursor structure to whatever the APIs change to. So developers who use this will kind of be immune to maybe API changes that cause breaks in applications. Like that, the layer of abstraction that's happening here will help shield them from this. So contract kit code generation is also kind of in full swing as well. I don't have anything to show for that, but I hopefully will in the not too distant future. We do have some very sampley versions of code generated stuff, I think, in here. Like this was a really old version, not really old, but you can see this itself is something that implements the contract kit. And this was, I think this was actually generated and saved. Like there was a command that was run that output this call, and it is a contract for this Decentium contract that we've kind of been referencing throughout this call. You can see it added methods to the contract. These are all the actions from the ABI that are all typed to act as helpers for people to perform transactions. It's going to make your IDE know what you can do with the contract and what types of variables it needs and all that other fun stuff. It does all the conversion of data types and is able to communicate with the session kit. A little bit more complicated one. This is where you create a post, whether it be you pass the author, the title, a document, which is a special type in the ABI, and then the metadata of the post. Let's get past all the actions. We have a namespace with all the types that are defined from the ABI. These are for both defining what's expected as well as to optimize API calls. We can pass these into a transact call and prevent any need to call get ABI from an API. All the tables are defined. All the names are automatically generated as well. So if there is, hopefully they make sense based on what the actual ABI and the smart contract have defined. But if we need to change how those are generated, like, we're very open to feedback on that. Yeah, I guess that is it for what an example contract looks like today. There's still a few missing things. Like, we want to add a tables array onto this contract so you can easily just magically get tables out of it. You have your contract object, you could call get table, or maybe there's an array of tables that you could just pull one out of, and it'll give you one of the table objects that we've been talking about for the first half of this call. So contract kit is really starting to come together. Yeah, I think that's about it where we're at on that. And then as far as everything else, the website is still progressing. The documentation's starting to look good. If you go poke around on the website, GitHub repo, you can kind of see that happening. Somebody pushed a commit a minute ago. There's dev builds and some of the pull requests where you can see what's going on there. I won't dive too deep into that today. But yeah. So yeah, I mean, that's kind of where we're at in terms of overall progress. Milestone 1 we reviewed last week, or not milestone 1. Milestone 5 we reviewed last week with the ENF. They're kind of looking into that right now, and that one might be marked as complete soon, and we're kind of full swing into milestone 6 being the contract kit. So approaching the halfway mark on this project. So yeah, I guess, Eric, did you have any questions or comments or anything like that, or?
No, I don't. I mean, I don't do as much of the querying by row as some of the other folks on previous calls have done.
Yeah,
So
unfortunately.
I don't have a lot of comments on it, but they look like cursors. They make sense. The API makes sense. Yeah.
So yeah, unfortunately, I got a couple messages about people that couldn't join today, but figured we'd run it anyways. But yeah, hopefully we'll get some feedback. I guess asynchronous discussion for anybody who is listening in on the WharfKit root repository or the organization. There's this discussions board. We've been trying to start using this now, just for asynchronous chatter about things. We talked a little bit about the app name a couple weeks ago, and then I started a thread on it. We've gotten a little bit of discussion going on that one. And we should probably get something up about tables here soon. So yeah, I guess just as a note for those who want to join in that are watching this after the fact.
Yeah, it's nice to see the documentation coming along too.
Yeah, it's hard figuring out a way to effectively put all the knowledge you have into one comprehensive thing. I can definitely say that, but it's coming along, and I'm going to be excited to be able to reference people to those things. Somebody asked a question earlier today about signatures. And so that's where this commit came from. I just pushed the document that I had about signatures up to GitHub. There's obviously no written explanation of anything yet, but somebody specifically asked, like, how do you recover a public key from a transaction? So I was like, well, I have the document just for that. Let me publish it. So there's a lot of this in the works, and hopefully it'll be good reference material rather than us just pointing people to the unit tests, which is what we have done for years. So not everybody can grasp the unit test quite as easily as they could a code example like this. Cool. Well, I don't think I have anything else to cover today. So if we want to wrap it up at this point, um, seems like a fitting place.
Sounds good. Thank you, Aaron.
Yep. Thank you very much.